When the ancients looked at the sky was full of mystery and wonder. And in the year 1066, the most important date on the British calendar, there was a comet which sailed over the battlefield of Hastings. It frightened the troops of King Harold, and a young man from Normandy swept into England and defeated King Harold at the Battle of Hastings, creating the modern British monarchy. But the question is, where did the comet come from? What was this comet that mysteriously paved the way for the coming of the British monarchy? Well, believe it or not, that same comet, the very same comet that initiated the British monarchy, sailed over London once again in 1682. This time, everyone was asking the question, where do comets come from? Do they signal the death of the king? Why do we have messengers from the heavens in the sky? Well, one man dared to penetrate the secrets of comets, and that was Isaac Newton. In fact, when Isaac Newton was only 23 years old, he stumbled upon the universal force of gravitation. According to one story, he was walking on his estate in Woolsthorpe, and he saw an apple fall. And then Isaac Newton saw the moon. And then he asked the key question which helped to unlock the heavens. If apples fall, does the moon also fall? And the answer was yes. And that answer overturned thousands of years of mystery and speculation about the motions of the heavens. The moon is in free fall. Just like an apple, the moon is constantly falling toward the earth. It doesn't hit the earth because it spins around the earth and the earth is round, but it's acting under a force of gravity. So Newton immediately tried to work out the mathematics, and he realized that the mathematics of the 1600s was not sufficient to work out the motion of a falling moon. So what did Isaac Newton do? When he was 23 years old, not only did he stumble upon the force of gravity, but he also created calculus. In fact, he created calculus at the rate at which you learn it when you're a freshman in college. And why did he create calculus? To calculate the motion of a falling moon. The mathematics of his age was incapable of calculating the trajectories of objects moving under an inverse square force field. And that's what Isaac Newton did. He worked out the motion of the moon. And then he realized that if he understands the moon, he also understands the motion of the planets in the solar system. And Isaac Newton invented a new telescope. It was the reflecting telescope, and he was tracking the motion of this comet. Well, it turns out that everyone was talking about the comet, including a rather wealthy Englishman by the name of Edmund Halley. So Edmund Halley, being a wealthy merchant, decided to make a trip to Cambridge to talk to England's illustrious scientist, Sir Isaac Newton. Well, Edmund Halley asked Newton, what do you make of this comet? No one understands comets. They're a mystery. They've been fascinating people for centuries, for millennia. What are your thoughts? And then I paraphrase, but Isaac Newton said something like this. He said, oh, that's easy. That comet is moving in a perfect ellipse. It's moving in an inverse square force field. I've been tracking it every day with my reflecting telescope, and the path of that comet conforms to my mathematics exactly. And of course, we don't know what Edmund Halley's reaction was, but I paraphrase. He must have said something like this. For God's sake, man, why don't you publish the greatest work in all of scientific history? If correct, you have decoded the secret of the stars, the secret of the heavens. Nobody understands where comets come from. And then Newton responded and said, oh, well, it costs too much. I mean, I'm not a wealthy man. It would cost too much to summarize this calculus that I've invented and to work out all the motion of the stars. And then Haley must have said this, "Mr. Newton, I am a wealthy man. I have made my fortune in commerce. I will pay for the publication of the greatest scientific work in any language." And it was Principia, the principles, the mathematical principles that guide the heavens. Believe it or not, this is perhaps one of the most important works ever written by a human being in the 100,000 years since we evolved from Africa. Realize that this book sets into motion a physics of the universe, forces that control the motion of the planets, forces which can be calculated, forces which govern the motion of cannonballs, rockets, pebbles, everything that moves according to the laws of motion and the calculus of Sir Isaac Newton. In fact, even today, when we launch our space probes, we don't use Einstein's equations. They only apply when you get near the speed of light or near a black hole. We use Newton's laws of gravity. They are so precise that when we shoot a space probe right past the rings of Saturn, we use exactly the same equations that Isaac Newton unraveled in the 1600s. That's why we've been able to unravel the secrets of the solar system, complements of the laws of motion of Isaac Newton. So what Newton did was not only did he set into motion the ability to calculate planets, he also set into motion a mechanics. Machines now operated upon well-defined laws. Newton's 3 laws of motion. The first law of motion says that objects in motion stay in motion forever unless acted on by an outside force. You see that in an ice skating rink. You shoot a puck and it goes all the way down forever unless acted on by an outside force. That's different from Aristotle's law of motion. Aristotle said objects in motion eventually stop because they get tired. The second law of motion says force is mass times acceleration, and that equation made possible the Industrial Revolution. Steam engines, locomotives, factories, machines, all of it due to the mechanics set into motion by Isaac Newton's second law of motion, force is equal to mass times acceleration. And then Newton had a third law of motion. For every action, there's an equal and opposite reaction. That's the law of rockets. That's why we have rockets that can sail into outer space. So the lesson here is, when scientists unraveled the first force of the universe, gravity, that set into motion the Industrial Revolution. A revolution which toppled the kings and queens of Europe, which displaced feudalism, ushering in the modern age, all because a 23-year-old gentleman looked up and asked the question, does the moon also fall? You know, when I was a kid growing up in California, I would see pictures of the Empire State Building. And I said to myself, how could they possibly build such a big building and not know that it's going to fall? Why doesn't it fall? They didn't build scale models of the thing. You couldn't have an Empire State Building that big to test whether it's going to fall or not. How did they know ahead of time that that building wouldn't fall? And the answer is Newton's laws of motion. In fact, today I teach Newton's laws of motion, and you can actually calculate the forces on every single brick of the Empire State Building. Using Newton's second law of motion, force is mass times acceleration. When Newton unraveled the force of gravity, that was the first force.